Many of us are moving our collections of physical floppy disks to all digital disk images, which can be used in emulators or written back to brand new floppy disks or used with things like the 1541 Ultimate 2. I have been engaged in a project for a couple of years of trying to locate and preserve SID player music, specifically music that was given away at in-person events called SID Fests. And I have found quite a few diskettes, both in my collection and a good friend, Craig Chamberlain. And we have made images of all those disks, which of course are not protected. But some of the disks had errors due to corruption from age or exposure to elements or magnetic fields or whatever. So I developed a method of fixing those images. Since they are special and were commemorating events that happened many years ago, I decided I didn't want to just erase corrupted files using disk routines and rewriting the file, but actually to replace the individual bad sectors in place on the disk. So you can think of it as kind of a forensic restoration of the disk image, changing as little as possible, just fixing that exact sector by putting the good data on top of the bad data and leaving everything else undisturbed. So to do that, I had to develop a method, and many thanks to people out in the world, Goog, Agent Friday, Pina Colada, other people like that who are all in the Puget Sound Commodore group and the Portland group. They were quite a bit of help, helping me figure out tools and methods for doing this. So the first thing is to understand a little bit about the D64 file format. And I'm not going to go into this in any detail, but you can check this out later. It's unused ino.de/ec64/technical/formats/d64.html, and it breaks down the format of a D64 image. And that helped me understand how the bits were organized from the physical 1541 disk into the image that you can see and manipulate on a modern computer. I'm using a Windows PC, but it could be done other places just using different tools. So basically, the diskette image is a stream, more or less. They start with the tracks and just go all the way through track 1, sector 0, all the way through. So there's nothing special about where the BAM or the directory live in the image. It's where they would be sequentially be on track 18, sector 0, and sector 1, etc. And at the end, the one thing that is special is at the end of the disk image is a table, and there's one entry for each sector, and that's where it's recorded whether there is an error in that sector or not, when that becomes important later in this task. So let's close that. And so from that web page, I was able to make an Excel spreadsheet, which I will share with this video. And that spreadsheet then gives me a shortcut way to know where in the disk image to find a given sector. So this is just a sequential number here, and then this is the more familiar track and sector. It goes from 1 to 35, and I don't have tracks past 35, which I know are possible, but I'm dealing with unprotected images which use standard DOS disk routines which never go past track 35. And then here are offsets in both decimal and hex for where in the image a given sector would be. And we'll talk more about that in just a minute. So the next tool that is really helpful is Durmaster, and I'm sure many of you watching this have used Durmaster before. It is just a great all-around tool for looking at disk images and rearranging files on them, looking at directory entries, etc. So in this case, this 011 Columbus, I guess I don't have to double-click it since it's already open. I'll just drag it. Is the image that has trouble. Fortunately, there was no corruption on the directory track or the BAM. When that happens, that can be really, really hard to repair. And you might have to use a utility like 64copy, which has the ability to find lost file chains. So if you have a corrupted disk entry, but you know something about the signature of some of the files you're looking for, you can generally retrieve them by hunting for that signature with 64 copy, and it can find all of the linked sectors that have that information as part of the chain. And then this image here is the image that contains the files that are uncorrupted. I was really lucky to find one, Demonger X, I hope I'm pronouncing that right, I don't really know for sure, has a fantastic library of disks at scenebase.org, and this particular image happens to contain most of the files I needed to fix the image on the left. That was really lucky. So it's good to have these open in Duramaster, just to refer to while you're doing this procedure in case you get confused or anything about where you are. The next tool you'll need is D64 Editor. So let's open that tool up. And what it does is various kinds of surgery on disks at a sector level. It's kind of like a reimagination of sector editors that many of us have used back actually on the Commodore, operating directly on physical disks, where this operates on images. So we need to open the corrupted image to start with. So let's do that. Okay. Huh. I thought I clicked on... Oh, right. He's got lots of stuff on his desk. That's why we're seeing all this. This is my son's computer I'm doing this on. So let's open up the corrupted image right here. And we can see right away that it's a 35-track D64 file, and there is error info. So it's reminding us or telling us that, in fact, there's at least one error on the disk. And one way quickly to tell whether a D64 image has errors in it or not is if you look at the file size in Windows Explorer, it'll say it's a 172K rather than 171K. It just so happens that the addition of that error table at the end causes it to grow by at least half a K to cause the file size to bump up. So the first thing you have to do, because you can't tell just from looking at the directory entries, is where is the corruption on the disk. So you can go to the View menu and choose View Error Blocks, and that then will identify where the errors are. Every block will have a number in it, and 01 is the choice of the gentleman who built D64 Editor to indicate no error. In fact, if you click on a sector, I just clicked on track 1 sector 0, you can see what the various errors are. He has codes that he uses, as you'll see here, hex codes that correspond to the various decimal disk error numbers that we're used to from Commodore DOS. And the most common one you'll find on an unprotected disk that has corruption due to age or whatever is number 5, which is a generic old 23 read error. And we don't need to save changes. So now we can go back and see, okay, you can read the tracks along the top, sectors along the side, and you can just go through methodically and figure out where all the errors are. So you would want to make a list by track and sector of where each error is. And so if we bring up Notepad, for example, let me do that. Let's see, does he have it on his desk here? No. So I'm going to start Notepad. All right, there's Notepad. So what we might do is, I'll just do a few of these here. We can hover to make sure we get the correct track and sector, because it can be a little hard to do the rows and columns eyeballing it. Hover there, and you see down in the middle bottom it says track 7 sector 17. So I would put in 0717 and then carriage return, and then none of these first two tracks, or a few tracks, and then none of these two tracks, and the next one appears to be here, track 10 sector 9, etc. And so what you want to do is go through and list out all of the errors on the disk first, and by disk I mean disk image, of course. Okay, so, and it'll say any changes, right? I didn't make any changes, but it doesn't actually know one way or the other. It just always gives that message. And then what you want to do is go to the Edit menu and choose Edit BAM. And now what you can do is take each track and sector one by one and find it here. The map is arranged the same way. So 717 is down here. Again, you can hover to make sure you've got the right one. and click, and it will tell you what file name is associated with that bad sector. So we'll type that in right like that. Okay, so now we know that's what that one is, and then we can close. We could use forward and back arrows to go to the next block, but it's several tracks away, which is a lot of clicking, so we'll just close and go to track 10 sector 9 right here, and we have another file name. Etc. So again, you would do this for all of the sectors that you identified as bad with the previous step. Okay, now the next thing you need to do, again, it's warning us about any changes, which we haven't made any changes. I typically don't change the images using either of those two screens. It's just for getting information. The next thing you need to do then is take the first file, manhattan.mus in this case, and find it in the directory. So there it is right there. Click on it to select it, and then go to View and view the file chain, because the next thing we need to find out is track 7, sector 17. What sector is that in the sequential chain of sectors that form that file as it sits on the disk? So we look for 717, and there should be a number there because that is a number from 1 to n, which is the length in sectors of the file. And if we go down to 17, we see 6. So in fact, what that means is it's the 6th sector in that file. All right, and then we'll close because that's the only one we're doing for this file. Yeah, I know. Thank you for reminding me again. say/goodbye.mus, and this is two similar files, but one is mus and the other is wds. Okay, oh, wrong thing, sorry. View file chain. And 10.9 down here is the 3rd sector. Okay. So again, you would do this for all of the bad sectors on the disk. And then once you have that list, then you are pretty much done with the D64 editing tool. And I'm going to go ahead and close it because I think if we try to open that image in another editor or another program, it will have a file lock on it. So we'll just close that all the way down. Yes, no changes, don't worry. Okay, so the next tool you need then is a tool called HXD, which is a wonderful hex editor. I believe it's shareware, and I've used it a lot. And so I always try to contribute to authors that have great shareware. So if I remember right, this is shareware, and I'm pretty sure I donated. So what we're going to do now is look at the good file and the bad file side by side. So we can just drag them in here like this, and I prefer to have them tiled so we can actually literally see them side by side. And unfortunately, the tiling algorithm on this program it always makes them horizontal, which I want to have it vertical side by side. I just prefer it that way because I can see more of each file since each row is fairly short. So I'm going to do this like that. Okay, and maybe shrink this up just a little bit. All right, now you want to be careful with HXD that you don't make the window too small, because it will actually start wrapping the rows and you won't get the rows matching the offsets in the Excel file, and that can be really confusing to pay attention to visually. All right, so what we're going to do now is we know that track 7, sector 17 in this file originally is where the corruption is, and that is the 6th sector of the file. Oh wait, duh, I completely forgot. Of course, we also need to find out the track and sector where the corresponding copy of the good sector is in the good file. So totally spaced on that. Let me just go right back here to D64 editor. So you have to repeat the same process basically, and look at it in the boy, I really screwed that up. I want to open the good image, not the bad image, sorry. So we need to go find the good image now, which has a different kind of name. There it is. It's got a scene base name. All right, sorry about that. So let's go to Manhattan, and again go to file chain, and we want the 6th sector of Manhattan.mus, and so we look for it here, and it is track 3017. So we can just put more numbers out here. However you might want to do that. That's kind of the way I usually do it. And then we go to say goodbye right there, view file chain, and we want the 3rd sector, which is 1220. And there we go. All right, so now we're ready to close D64 Editor and use HXD. So let's see where it's right here. Okay, and so I'll just squeeze this down a little bit so it can all fit on the screen. All right, so we have the corrupted image on the left, the image with the good files on the right, and a list of track and sectors over here. All right, so we need to go in the bad image to track 7, sector 17. So we look at our Excel spreadsheet, which we can also make small, and we can even squeeze it down a bit like that, and then make Notepad a little smaller like this. There we go. All right, so we look for 717, and there it is. And hex HXD is a hex editor, so it uses hex notation. So we need to go to 8F00 in the bad image, and so just kind of scroll down till you get close. And what I normally do is select the area I'm going to paste over, because you can do a insert paste or a write over paste. And I'm going to do an overwrite. So each sector is 256 bytes. The first 2 bytes of each sector are the track and sector link to the next sector, and so you don't want to change those, of course, because you have to maintain the integrity of the list of sectors in the image. So you start 2 bytes in, and you select 254 bytes, which is FE in hex. And so if you go down to the end there, and you'll see in the status bar of HXD it says length : FE. So I've selected the right amount, and then I go over here, and it's track 30, sector 17 in the good image, and so I will go down to 30. 17, which is 2550, and we will head down there. Oh, it looks like I made the window just a little too narrow, and I've lost my scroll bar somehow. Oh, I see. I grabbed the outside of the window rather than the inside. Okay, that's better. All right, so now we'll go down to 2550, which is quite a ways down in the image. Scrolls pretty quickly though, so it's not a big deal. All right, scrolling, scrolling, scrolling. All right, so 2550. And again, we select, as you can see, as I'm selecting, the length amount changes. And we go here, and we have FE bytes, or 254 bytes, selected. Now, what you should see is that some of the material in that sector should be the same. Did I select the wrong thing? 25500. Oh yes, I went 25500, not 25550. So that's a demonstration of why you always want to check the first few bytes, assuming that the corruption didn't start with the very first byte of the file, because sometimes it's easy to select the wrong thing, which I just did. Okay, so if we compare then old image to new image, we see the first several bytes are the same, 1498709A, 0C exact, etc. Sometimes what I do is I look at the last byte of the line and to see if they're the same, just to see how much of the sector is corrupt. Is just kind of interesting to see how that works. And the way that Commodore sectors work, the way the disk works, GCR, is once there is a bad byte, all the rest of the bytes will be wrong. So we can see it's good for the first row, 1517969494, boom, and there we go. This line right here ends in a 9D in the good image and ends in a 9. Oh, no, I got that wrong. Sorry, 9D still right. 200223DF. There we go. That's the bad one. So this one ends in DF, and in the bad image it ends in B0. And you could go back and see where exactly in the sector the corruption starts. So you could select just the few bytes that are actually bad, but I usually take one sector at a time. So I just edit copy or shortcut Control C, and then I click to make sure I've got the other window selected, because you don't want to just paste over the top. And then you'll notice on the edit menu there are two paste commands, paste insert and paste write or overwrite. And I will always be using Control B, the overwrite, because we're replacing bytes that already exist. And so if you choose that, it'll turn them red until you save the file at least. And so now what you see is that we have fixed that sector because we have overwritten the entire sector with data from a known good file. Okay, so once that's all done, with all the bad sectors, you can remove all the errors from the error table. So if you scroll to the very end, you will see a table starting at 2, let's see, where is that? Oh, right, it'll be in this file, not that file, because this file will be longer because it actually has the error table. So this, the good image, ends at 2AAF0. And so if we go back here, 2AAF0. So everything starting at 2AB00 till the end is the error table, one entry per sector on the disk. So I guess this adds up to 664 blocks, because that's how many blocks. Well, but no, you have to include the directory and the BAM, don't you? So it's slightly more than that, whatever that turns out to be. So what you can do is, if you're repairing the disk a little bit at a time, you can locate each sector, if you do the math, based on offsets, and change the individual errors back to 0, 1. So for instance, you can see right here, there's a 0, 5 here. So if you happen to fix that sector, you could change it. What I usually do is wait until the entire image has been fixed, and then I just select the entire error table, everything after 2AAFF, starting with 2AB00 in other words, and go to the edit menu and delete it. And it will ask, if you really want to do that because you're changing the length of the file, which is typically not a good thing to do with binary files, but in this case we actually want to do that. And so now we've shortened up the file. And if we save it like that and go back to D64 Editor and open the file, we will see that it doesn't think there are any more errors. There actually still are, because there's a whole bunch more sectors we haven't repaired yet, but we have removed the error table, so it believes that it's a completely uncorrupted image. Well, I hope you enjoyed this short tutorial, even with all my mistakes, on how to forensically fix a D64 image. And if you have any questions, feel free to contact me. Thanks.